This is our third session, the third time I've stood up here and talked about Unity. And all we've talked about so far is setting up the environment, getting the tools, where do I download this, how do I install that. So now that you've actually got some tools, what are you going to do with it? The first thing that you're going to want to do is get some objects to bring into Unity. Now, whether you've made them or somebody else has made them, or I've imported them into my project from Sketchfab or TurboSquid. Actually, before I even want to do that, I want to do something with the lighting. I'm not going to talk a lot about lighting. All right, I'm not going to talk very much about the different lighting systems because I'm planning an entire discussion just about lighting. But what you're going to want to do is you want to go to Windows, Rendering, Lighting Settings, and then down at the very bottom, there's a button that says Auto Generate Lighting. You want to turn that off. For some strange reason, that's on by default. And if your scene is very simple, you won't notice anything except a little blue bar flashing in the corner of the user interface every once in a while. But once your scene starts getting remotely complicated, baking the lighting is going to take a little while. And you want to make sure that you have your lighting environment set up before you start baking your lighting. But Unity wants to start baking the lighting right out of the box from the very beginning. So you'll save yourself a lot of processing power and headache wondering why my user interface is slowing down all the time if you just turn off auto generate lighting until you're ready to use it. Okay, so now getting to the first thing that we would be working with. When I've got an object, I'm getting ready to bring an object into a scene. Could be a model, but yeah, it's probably some kind of model, a character or a set or a car or a prop or whatever. I want to find that object in my project folder. I want to select it and look at the options in the inspector, right? So I'm looking at the import options for this model before I even bring it into the scene. Basically what I'm doing is I'm telling Unity how I want to handle this model on the project level. And there's a ton of options that Unity uses when it imports these models. And there's a few things that we want to change before we start working with our model because we're getting it ready to be used in Altspace. So the first thing I want to do is I want to turn off import cameras and import lights. Some models, especially if a model is made with Blender, will come in with 2 lights and a camera attached to it, just part of it. They just stick it in the model. And some packages don't. 3D Studio does not, for instance, but some packages like Blender do. And in some environments, that makes it easy because I just bring in the model that's got the camera and lights with it. But we don't want that when we're developing for Altspace because Altspace already has its own cameras and we're going to be doing our own thing with the lights anyway. So you might as well just turn those off so that even if they are in the model, they don't come into Unity. The next thing I want to turn on is generate colliders. Generating colliders will make it so that this is a solid surface. And what that does is Unity will auto-generate what's called a mesh collider. There's different kinds of colliders. We're going to talk about colliders in a second, but mesh colliders are a special case of collider that tells the Unity game engine that this is a solid thing, that it will stop something and prevent something from going through it. So you want to generate your colliders, and then down at the bottom, I want to generate light mapping UVs. I want to turn 2 things off and turn things on. There's another setting in here with read write enabled is purely optional. If you don't turn that on, Unity may give you some meaningless error messages that don't really matter. So you could silence those by turning on read write enabled, but it's not really something that we use a whole lot. Yeah, there's a question, Ron.
Yeah, I went to, I forget where, and I imported the model.
Mm-hmm.
So I downloaded the model. And it looked like the model was made for a 3D printer. Can I use that kind of model in Unity, or is there a different one?
You can use those like it was an STL file, right? Probably if it came from a 3D printer, right? So yeah, Unity can import STL files. The problem with STL files is they're typically very heavy. When I'm 3D printing an object, I want to put a lot of details into the geometry, and I want the geometry as high a resolution as possible. That's going to make a very heavy model when I bring it into Unity. It's also not going to have any textures on it, and it's not going to have any UV maps, so it's always going to be a solid color. But yeah, aside from those two things, yeah, you can use STL files.
So what kind of files should I be looking for?
You should be looking for FBX files, right? The FBX is it's a file format that was actually designed for video games. So Unity reads it in, lots of packages write it out. It's a pretty common format, and it can contain a lot of information. So I can embed lights, cameras, I can embed materials and textures and animations. I can embed multiple stages of the object. Pretty much the entire scene can be contained within an FBX file. So it's very powerful and very common. There's also an OBJ file format that is also very common. It's also very old. It was one of the very first 3D file formats. If I have an OBJ file, I'm also going to have a corresponding MTL file to define the materials. And then I'll probably have a bunch of other images that go along with it. If I have Blender installed on my machine, I can read Blender files into Unity. And that's really convenient. If I'm working with Blender and I'm saving my blend files into my Unity project folder, I only have to have one copy of that file. I don't have to convert it or translate it into anything. Unity and Blender both are able to read that same file. That's super convenient. And then there's probably about 20 other different file formats that Unity can support, but those are the big ones. FBX, OBJ, blend files are probably the ones you're going to come across the most. So let's see. Turn off lights, turn off cameras, generate colliders, generate light map UVs, and now my model, and hit apply, because I have to apply those settings. And when I hit apply, it's going to have to re-import that model. So that could take, if it's a big model with lots of textures and something, it could take it a little bit of time to re-import. There's other things that we could do with this in terms of animations and materials, but I'm going to save that for another event. On the subject of mesh colliders, I get a lot of questions about mesh colliders, about how to control where I walk and going up slopes and stuff, and how do you do that? If I have an object and I want to be able to sort of glide over it or stand on it, it has to have a collider attached to it. I could add colliders as components to my game object once I get the object placed in the scene. But then I have to, take this square thing and try it fit, or take this round thing and try and make it fit. But if I generate mesh colliders, Unity goes through and it looks at the geometry when it imports it and figures out what parts of this surface I should be able to bounce off of and not. Now when I look at the mesh collider component, right? So any object, if I look at my game object in the editor, and does everybody remember, the user interface? We talked about it last week. All of my game objects will show up in my scene, and if I select it, I'll see it in the hierarchy, and all of the components that are attached to it will show up. So I'll see this mesh collider component attached to my game object when I select it in my Unity scene. And really the only thing that makes any difference in Altspace is that top option for whether or not it's convex. Triggers don't work. Cooking options, it's not really supported. Physics materials, none of the rest of that stuff is either supported by Altspace or important for what we're trying to do with it. So the only thing that you should really worry about on this mesh collider component is the convex option. What convex does is it sort of shrink wraps the object with the collider. Normally, the collider is going to exactly follow the contours. The collider is going to be generated out of the actual geometry. Those types of colliders, I can't use it in, say, a game. I won't be able to pick that up and bounce it or shoot it or something in a really complex physics interaction. Because a mesh collider that way is just too complicated for the engine to handle. So it wants it to be convex. Convex puts a much more simplified mesh. Once again, it's invisible, you won't be able to see it, but it wraps the object in a simplified mesh that sort of fills the gaps that are sticking out from it. So if you look at this example here, this block over here on the left, where the L-shaped block is a mesh collider as Unity would bring it in. It would follow the contours of that shape. But if I want to be able to use it, say, pick it up and throw it, then the mesh collider has to be convex, and Unity's going to generate a collider that goes across those corners there and making a convex shape, hence the name. I like to think of it more as shrink wrapped because it looks like it'd be wrapped in plastic than thinking of it as convex or concave. Because then I have to remember, okay, which one's convex and which one's concave? But shrink wrapped, you know, that sticks in my mind a little bit easier. Now, what difference does this make in Altspace? Most of the time, I just use the regular mesh collider because it's simple enough, right? And it'll follow nice slopes, and I'll be able to go up gradients and over humps and down through dips and stuff. It'll be nice and smooth. But stairs become bouncy. So if I build a set of stairs and that I bring that stair object in as one model and I give it a mesh collider, I'll be able to walk up it, but there'll be this annoying jitter every time I go up each step. But if I put a convex mesh collider on those stairs, then it's going to go across the top of the stairs, and then I'll just glide smoothly up that convex mesh collider as it seals over those points on the face of the stairs. Now the downside of this is that it can also fill in holes that I want to be able to go into. Let's say my stairs are curved, right? So I've got a circular set of stairs. I put a convex mesh collider on it. It's going to cut across that curve, and I won't be able to move my avatar inside the curve of those stairs because they'll be sort of encased in this shrink-wrapped collider. I may still be able to smoothly go up it, but I won't be able to go inside of it. And if I have, say I'm bringing in a house, and the house is coming in as a model, and I generate a collider on the walls, and I make it a convex mesh collider, that's going to keep me from being able to go through any of the doors or windows or being able to move very well inside the house. So you really want to pick and choose. There's definitely times in Altspace where you want your mesh colliders to be convex, and times when you don't want them to be. You know, it all comes down to your freedom of movement that you want to have. Anybody got any questions on this? It's kind of a topic. Okay. So now, after I've done that, I'm ready to bring my objects into the hierarchy. And there's two ways that I can add objects to my hierarchy. I can actually go over to the hierarchy itself, click on the Create button, and then I've got a whole host of things that I can add to my hierarchy, and it will just create them in the scene. And as I mentioned last week, when I do this, the objects that I add to my scene only exist in my scene. There's not another copy of them in my project. So they don't have that prefab connection. But if I drag, say, one of my models out of my project folder, drag it over and drop it in my hierarchy, then there will be a prefab connection. If the model or the prefab changes on my disk, it's going to change in my hierarchy. Now, what may happen a lot of times, sometimes Unity is really good about allowing me to place an object on top of another object and place it exactly where I want to in the scene. But sometimes if I drag it over and just drop it in the hierarchy, there's really no telling where Unity is going to put that object in the scene. So right off the bat, I'm probably going to have to move it someplace closer to the rest of my geometry. All right, so give me just a second to redecorate some of these. Yes.
We got a couple projects for a couple work I'm doing, but I import some models,
Mm-hmm.
download models and import, and they import into their project. When I create import into the project, and all those models are gone, I have to re-download and import them. Is there a recommended way to keep a single instance of a set of models that I might want to reuse? So I'm not downloading or trying to do the models that they've gone over.
Right. So what I do, and last week I talked a little bit about quarantining your assets. When I download my assets, I put them into a separate folder, and so I can take those assets apart and see what else is in there, and then I only want the stuff that I want to have in my project. Then I move that over into my project. And what eventually I'm doing is I'm building a library of assets that I can use over and over and over again. So when I take these in,
Some redundancy between projects.
yeah, yeah,
Okay.
yeah. Not really, not really. Well, if I know that I have a set of assets that I'm going to want to have in every project, sometimes what I'll do is I'll make a backup of that project folder when I first get started with it, and then use that as the basis for other projects. So they would have, but once again, I'm just making a copy. I'm still just making a copy. All right. So I've got my objects in the scene, and I need to move them around. I need to modify their transform, which is, as we were talking about last week, is the location, the orientation, and the scale of my objects. That's what the transform basically pertains to. And I have a collection of transform tools that I can use to modify the transforms of my objects. And if you've seen any other kind of CAD package or drawing package or even a simple little modeling package, SketchUp, you've seen tools that are like this, because all of these 3D environments have a similar sort of workflow in terms of how these things are modified and maintained. So I have a move tool, I have a rotate tool, I have a scale tool, and those are the three tools that are really going to allow me to do anything I want to with my geometry in terms of its identity. Each axis, so each of these tools has three little lines on it for axes. Each axis has a different color associated with it, so I can tell by looking at it which way I'm moving or which way I'm rotating my object. Also, by clicking on one of these axes, I can constrain that motion. So if I've got an object and I only want it to move up and down, I can select the move tool, and then on that little the top gizmo there, if I grab just the green arrow, then it will only move up and down. The same thing with the blue, same thing with the red, and then I've got that little gizmo right in the corner, little right angle looking things. So if I click on the red square, then I'm constraining it to a plane. It'll move in that'd be the Y and X and Y plane. And then I can move it in the X and Z plane by grabbing the green square. And the same thing with the blue. So I can constrain my motion to either a line where I'm moving back and forth, or I can constrain it to a plane. And by using that, that allows me a lot greater control over how I line things up. And lining things up is really going to be probably one of the greatest challenges, trying to make sure that, oh, my columns are all lined up, or the stairs the right height. You're going to be looking at things from a couple of different ways to make your world line up right. The rotate tool works in a very similar fashion. I've got these different colored circles around the sphere, and if I grab one of those and turn it, then it will lock that rotation along that plane. It'll only rotate around either one axis or the other. If I grab the sphere anywhere else on the sphere, so I don't grab it on any of those axes, and I just grab it and start dragging it, now I'm freely rotating it. And they actually rotate in two directions at the same time, depending on what kind of effect you want. Same thing again for the scale. I can grab one of these green bars down here and scale my object along one of the axes. in whatever way that I want, or I can grab the little white square cube in the middle and scale them evenly along all three. Now there's two other tools that Unity has. There's one that they call the Rect tool, and they actually spell it R-E-C-T, but I think of it as the Rect tool, the W-R-E-C-K-E-D tool, because it more often than not screws up the alignment of my objects for me. It's kind of a new thing in Unity. I'm not a super fan of it. It has its uses, but it's also, it can get away from you pretty easily. But what it does is it allows me to grab, say, puts a pair of grips on my object, and I can just sort of randomly scale in different directions and distort my object to make it fit within a certain space. But if what I found is that if my object is rotated a little bit when I start grabbing it, I get unpredictable results with it. So it's a new tool. Maybe they'll work out some of the kinks with it, or maybe I'm just not figuring it out. I'm not sure. And then they've got a combo tool that has all three of these combined. So I can scale, I can move, and I can rotate all with one gizmo. And which one I do depends on where on that gizmo I pick. It's tremendously powerful and maybe a little bit overcomplicated. But you have it available to you. I can also go to the inspector and explicitly type in my transforms. And there's going to be times where this is exactly what I want to do, especially if I'm designing around a certain point. I've said it before, you're going to hear me say it again before we're done here. I design around 0, 0, 0. So the first thing I do when I bring an object in is move it to 0, 0, 0. And then I start at 0, 0, 0 and move it to where it needs to be. And that way my design stays centered around my origin. One way to prevent me from falling through the seam when I start in. But it also makes it easier because if I'm going through for a type of symmetry, if I know that my world is aligned on the origin, that 0, 0, 0 is at the center of my world, if I want something placed over here and in the exact same spot on the opposite side of this axis, all I have to do is put a negative sign and transform in front of one of them and just mirror it over. So it makes it easier to figure out if I know where one is, it makes it very easy to figure out where the corresponding one on the other side goes if I keep everything centered around the origin. Lots of reasons for doing that. Scale, the units that the scale uses and the units for the, not the units for scale, the units for the position are in meters. So if I want to think of something as being a certain size, then I can think of how big it is or how long it is and think of that as being meters, and that's the way it's going to work out. Also, the physics engine in Unity and the lighting engine in Unity, they sort of anticipate that it's 1 meter per unit when they're doing their own calculations, so that things work out to have a kind of a real world sense of proportion and scale. And then the other good reason that you could do with this, different packages bring in models with different orientations. Unity is what we call Y up, right? So the Y axis is the one that sticks up. But other packages like 3D Studio are Z up, right? So the Z axis is the one that sticks up, if you can think of up. So when I bring something in from 3D Studio, a lot of times it's laying on its side because the axis that points up in 3D Studio is a different axis that points up in Unity. And I can fix that by putting a negative 90 degrees in one of these rotation values just to point it straight up. So you can use it to fix that issue. You can also use it to explicitly scale and position your objects. Another thing that I do to quickly move things or make sure that things are quickly aligned with view, if I click on that little gear symbol up in the corner, I'll get a bunch of options, 2 of which are reset position and reset rotation. I can also reset scale. If I do the reset up at the top, it's going to do all 3 of these, and that may not be what I want. But reset position is always going to move it to the origin. Reset rotation is always going to align it with whatever its parent is. In the upper right-hand corner of the Unity main editing, the scene window, you're going to see this little gizmo that's got a cube and a bunch of little cones sticking off of it. That's your view gizmo. It sort of shows and defines and controls which angle I'm viewing my model from. And it'll, as I move around my scene, this little gizmo will sort of move around to correspond with whichever direction my point of view is aiming at the model from. If I click on one of these cones, then my view will rotate around until it aligns with that axis. And so I've got one for the Y, one for the Z, and one for the X. And so I can click on the Y and go up and look straight down at my model, or click on the X and go to the front and look at the model. Same thing with the Z. And then the gray cones represent those same axes, but they're from the other direction. So if I want to look at it from the front, I can click on the X, the red cone, and look at it from the front. But if I want to look at it from the back, if I click on the gray button on the other side of the red cone, I'll swing around to the other side and look at it from the back. And a lot of times I'm going to be looking at my models from a bunch of different directions to make sure that things line up. And another important feature that will help you place your objects is switching back and forth between a perspective and an orthographic view. Now, the difference between a perspective and an orthographic view is that a perspective sees things in a natural way, like an eye would, with what they call foreshortening, right? So what they call the projection lines are moving out in a sort of in an arc. And what that means is that things that are closer to me look bigger than things that are further away. So that sense of foreshortening exists in a perspective view. In an orthographic view, all of the lines are parallel. So you sort of think of my line of sight is just going in two straight lines into my world. And what that means is that things that are farther away are the same size as things that are closer. And it's really sort of an intuitive, counterintuitive way to think about looking at something. But that's really the way descriptive geometry works, is I want to accurately describe by getting rid of that foreshortening, how these things are shaped and how they're arranged. And so, sort of to give you an example of the difference between the two, this is the exact same view of this world, but over here on the left I have the perspective view, and I can see over stuff. I can see around stuff. I can see the stuff in the background is smaller than the stuff in the foreground. It looks that way. It appears that way. And this is what the same view looks like with ortho turned on. Right? I'm looking straight on at the edge. I can't see anything over that wall. It looks like there's only one of those pads. It looks like there's only one of those columns. But what this does is this gives me a better view of how these things line up. I only expect to see one of those pads because I expect the pads to be lined up with each other, and I can check that when I'm looking in the ortho view. The perspective view is great to give me my look and feel, right? My sense of scale and perspective. But my ortho view is definitely what I want to do if I want anything to have any kind of precision with where I place it. I'm not going to get too deep into prefabs because prefabs are a subject that are probably deep enough to contain their own session. But I want to talk about nested objects and nested transforms. So a game object in my hierarchy can have other game objects as children of that game object. And any change to the transform of the parent gets passed down to the children. So in this example here, I have a sphere, I have a cube, and I have a cylinder. The cylinder is a child of the cube, and the cube is a child of the sphere. Now I can select any one of them and move them individually, but if I select the cube, the cylinder is going to move with the cube. If I select the sphere, then all three of them are going to move as one. The same thing with rotations, the same thing with scales. And this is really good for logical grouping. A lot of times I'll use my game objects sort of like folders, right? So I'll create an empty game object, and the only reason that game object is there is to be the parent for a bunch of other similar game objects. I can collapse that in my hierarchy, and I don't have to worry about it, and I can have access to all of those children game objects. So any change that I make to that game object, like I change its layer, or I make it static, or a bunch of other things that I'm going to be talking about, then those changes propagate down into the children of that parent, which is something to really be aware of, because when I'm looking at my transform component on a game object, that position is relative to its parent. So in this example, my sphere could be, say, at, I don't know, some arbitrary position. I can't randomly come up with 3 numbers right now. But my cube, if I look at the position of my cube, the position of my cube is not going to tell me its position in the real world. It's going to tell me its position relative to the sphere. As the sphere moves around, the position of the cube is not going to appear to change. Clearly it's changing because it's moving around through the world. But what Unity is probably going to tell me is its relative position to its parent. So that's just something to sort of keep in mind when you're looking at those values. If you see something that doesn't make sense, check to make sure whether or not the object that I'm looking at is the child of something else or the parent of something else. So at this point, we're just about ready to build. We've got our objects in, we've moved them into the right position. We haven't done anything with the materials yet, but that also is going to be another talk. But everything's ready to go, and I've got the uploader installed, and I hit build. What it's going to do is it's going to create a new game object in your scene called environment. And it's going to take everything in your scene and it's going to make it a child of that environment. That environment game object is what Altspace is looking at. When it opens up your asset bundle, it's looking for one object named environment, and that's what it's going to use as its template. And everything under the environment becomes part of the template. Now, the uploader is going to delete any cameras that it may find. So if you turn your camera off, it should be unaffected. Otherwise, it's going to be deleted. And then if I have any objects disabled, this is still something I'm a little unsure about. Normally, I know what the answer is. Objects that are disabled, like in this example here, the grayed out camera, the grayed out crescent are disabled. They still appear in my scene. They still take up space, but they don't come into Altspace. They don't appear. And I do that for a number of different reasons. Like my haunted house world, I've got objects that are scattered through there that emit light to light up the walls in different places. And I only turn those on when I'm generating the lighting. When I'm done with the lighting, I turn them off. They're still in the scene, but you never see them. You shouldn't see them. Also, what Altspace is going to do is, unless I have unchecked the auto layer option in the uploader. So if I look under the build settings, there's an option for disable auto layer management. I don't remember exactly what it says. But if I don't check that, I let it do its auto layer thing, then it's going to move all of my objects onto the same layer. And that's fine. Let it do that. Unless you have a particular reason to. That's not really going to be that big of a deal. I like to keep a camera in my scene because it gives me something that I can look at my world from. Also, a camera is the best way to see how the skybox is working. So for a lot of different things that we're going to be talking about later, especially when we get the skyboxes, you're gonna want to have a camera in your scene. And if you forget to disable the camera and the Altspace uploader destroys it for you, you can just always create another one. That is the end of my prepared material for today. Are we friends yet? Yeah, we're friends. Hit me up. Hit me up sometime when you see me online and go take a look at it. Anyway, I do have to run, everybody. I'm up against a hard deadline. Casey and Bray. I appreciate everybody showing up. Thanks for your questions. Thanks for your participation. I'm going to be repeating this on Monday at 10 a.m. If you feel like coming back. Otherwise, ciao.